Hello students, today for class 10 I am going to start real numbers. Real numbers, it consists of 6 marks. It consists of 6 marks. In this chapter, first we are going to learn a lemma. Lemma, L-E-M-M-A, lemma. What is a lemma? A lemma is a proven statement used for proving another statement. A lemma is a proven statement used for proving another statement. We must know this well. The chapter starts with this lemma. Here, as the lemma, we are going to know Euclid's division lemma. Euclid's division lemma. Euclid's division lemma, which is in short known as EDL. There is Euclid's division lemma. Now, what is Euclid's division lemma? Before to give the definition of Euclid's division lemma, let us show one division, long division method. As you know, suppose we are dividing 135 by 9. Then 9 1 ja 9, 4 5 45, this 5 comes, then 9 5 45, and there is no remainder, 0, means 0 is the remainder. So whenever we write 135 in previous classes, I think from class 5 onwards, you already know this division. 135, we can write this as 9 into 15 plus 0. Now 135 is what? This is known as dividend. Nine is known as divisor or divisor. 15 is known as quotient. And 0 is the remainder. So, for dividend, we can write as dividend is equal to divisor into quotient plus remainder. You already know this relation between. So students, you come to know that dividend is equal to divisor into quotient plus remainder. Now we have seen that whenever dividend A is divided by the divisor B, the quotient is Q and remainder is R. Therefore, we can write A is equal to BQ plus R, where R is the remainder and value of R will be 0 less than equal to R less than B. There is R can be 0, but R cannot be equal to B, always less than B. When R is equal to 0, what we have seen, whenever R is equal to 0 for this division, that is whenever 135 is divided by 9, we have seen that remainder is equal to 0. Remainder is equal to 0. Now remainder is equal to 0 means it is exactly divisible. That is 135 is exactly divisible by 9. So whenever R is equal to 0, then it is said that A is exactly divisible by the divisor B. Now, application of EDA, Euclid's division algorithm. Euclid's division algorithm to find the HCF of two numbers 288 and 78. Now what is Euclid's division algorithm? Division algorithm means Euclid's division algorithm. Algorithm means algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. Now Euclid's division algorithm, which we write in short as EDA, it is used to find the HCF of two or more numbers. For example, suppose we are using EDA, Euclid's division algorithm, to find the HCF of two numbers 288 and 78. So HCF of 288 and 78, what we see? Here we see that 78 is less than 288. So 288 is to be divided by 78. Now let us perform the long division. 288 divided by 78, first 3 here, then it will be 234, remainder will be 54. Now remainder 54 is less than 78, so no more division is possible by 78, so 78 comes here and we are dividing 78 by 54. 54 1 ja 54, remainder is 24, again 24 is less than 54, so 54 comes here, we are dividing 54 by 24, so 24 2 the 48, remainder is 6, now again 6 is less than 24, so 24 comes here, now 6 4s are 24, remainder is equal to 0, means long division method, division ends. And whenever division ends, we see that for the last division, the divisor is 6. So 6 is the HCF. Here we have found out the HCF of two numbers 288 and 78 by long division method. In our previous classes, like in class 6, 7, 8, we already have learned this one. But what is Euclid's division algorithm? As I have said you, algorithm means well-defined steps. You have to show the different steps, well-defined steps, which gives a procedure for solving a type of problem. What is our problem? Here our problem is to find HCF of 288 and 78 by EDA, Euclid's division algorithm. Now you see that here we have encircled 4 separate distinct divisions. First, 288 is divided by 78 when 3 is quotient and 54 is the remainder. So for this we will write, step 1, 288 is equal to 78 into 3 plus 54. Here the division is incomplete because r is not equal to 0. For the second step, we are dividing 78 by 54. So 54 is the divisor, 78 is dividend. Now for the step 2 we can write 78 is equal to 54 into 1, 54, okay, 54 into 1, 54 into 1, 54, so 78 is equal to 54 into 1 plus 24. Here remainder r is 24, r is not equal to 0. For step 3, 24 is the divisor, 54 is the dividend. So for step 3 we will write 54 is equal to 24 into 2 plus 6, that is 6 is the remainder, and obviously r not equal to 0. Now step 4, 24, we are dividing 24 by 6, so 24 is equal to 6 into 4 plus 0. Now here it is to be noted that the remainder r is equal to 0, means division ends. So the last divisor which is written inside the box, the number is 6. 6 is the HCF of the two numbers 288 and 78. We write it as HCF of 288 and 78 is equal to 6. Now working rules applicable to word problems on HCF. What will you do? Step 1, first, the largest number which can divide both A and B is their HCF. Second, the largest number which can divide, say, A, B and C is their HCF. Here we have taken more than 2 numbers. In most of the questions which are statement problem, word problems, how do we know that we have to determine HCF? To help you students, you will see that in the questions some words like largest, greatest, highest, tallest, maximum, most, etc. All these words will be used, which will help you to understand that you need to determine HCF of those numbers. Now, for today our discussion ends, and our next topic will be fundamental theorem of arithmetic. Till now you listen this video 1, 2, 3, there is many times, and try to understand what is taught in the video. If you feel any problem, you are always free to ask. Okay, so for today it ends.